All right, so just going to look at a few things for worksheet 14. So we're approaching here the end of Unit 1. And so not a ton of new things on here, but we'll go over a few. So just like we did yesterday, we see that our factor corner says factor to solve. So we still start the same way. So factors of 14. First I do 14 divided by 1, so that's 14. So 1 and 14 is my first set. Then I ask myself, is 14 divisible by 2? Which it is. 14 is 2 times 7, so I'll list 2 and 7. Then I would ask myself, is 14 divisible by 3? Which it's not. You can check on a calculator if you need to. Then I try 4. Nope. Definitely not divisible by 5. It's also not divisible by 6, which means I know I'm done with my list because the next number would be 7, and it's here on the other side. So 1 and 14, 2 and 7. So then I repeat the same factors, but with my negatives. So -1 and -14, -2 and -7. Then, for the factors of -14, I'm just going to rotate which of them gets the negative symbol. Sorry about the slow handwriting. I forgot my little pencil, so I'm having to use a mouse, and it's not nearly as effective or quick. All right, so there we've got all of our factors. So now I'm going to go over to my polynomial part. Remember that I am always looking for the factors of the constant. So in this case, if I look at my constant, it is positive 14. So I'm looking for factors of 14 that add always to the middle coefficient. And so in this case, my middle coefficient is positive 9. So in my list, I should be looking for the factors of positive 14, so meaning in this list, that add to 9. So hopefully you circled these ones. Those are our winners. So that means I factor into x plus 2 times x plus 7. Then, just like yesterday, we've got that to solve addition, which means that we also have this equals 0 in there. And so what we said yesterday is that we know that if two items are multiplying together and getting 0, that at least one of them has to be a 0 itself, which is why our next step is to take each of what was in the little baby parentheses and set them equal to 0. So x plus 2 equals 0, and then x plus 7 equals 0. So these are really small equations, one step to solve. So here I would undo the addition of 2 by subtracting. So I get x equals -2. And then over here, same idea, but subtracting the 7 on both sides. So x equals -7. So I've got my 2 solutions for x, and I'm done with the factor corner. Also, just like what we saw on worksheet 13, our sequence today is missing some terms. It does say it's arithmetic, so that's important. Yesterday's was a little bit easier because in our list we had 2 terms in a row. Here, we skip a term between the two terms that we're given. So here's the thing that has to be true. We know that if the sequence is arithmetic, that between every two terms, we are going to be adding or subtracting the same number that we call the common difference. So all of these, it's the same idea. So what that means is that if I'm looking at the two numbers that I'm actually given, which are 15 and 23, that means that between them, I have moved, and I just illustrated it for you here. This is one common difference added. This is two common differences added. So if I look at how far apart 15 and 23 are, that's 8. And that has to be D plus D or 2D. So two common differences in this case is 8, which means that one common difference has to be 4. So when I look at this, I'm then saying, okay, between each set of numbers, it needs to be adding 4. So 15 plus 4 is 19. To check my work, I do 19 plus 23, which that does work. So the 4 seems to be accurate. So then I need to go backward, 15 minus 4 to get this guy. And then my first term, 11 minus 4, should start at 7. And then I can double check it again by going through it forward. All right, so now you've got the sequence filled in, which means you should be able to do the pattern, the graph, the table, all of those good things. So flip it over to the back. We're going to look at a couple of things in here. So just a few reminders that this is review of distribution, and we've reviewed this many, many times. I'm not going to go through an entire problem in this section, but I am going to remind you that when on 2, 3, and 4, notice that there are very small differences in 2, 3, and 4. They look very similar, but there are small differences. You will get different answers on all of them. But remember on 2, 3, and 4 that you have to do both rainbows and smiley faces, because these are all double distributions. So remember, all of these should have 2 steps. You write out the 4 terms you get from your rainbows and your smileys, and then in the final step, you combine like terms. So make sure that you show all your work there. The next section, solve using opposite operations, show one step at a time. So 5 and 6 should be just pretty standard. We're going to look at 7. So if I'm trying to get x alone, my first thing that I would do is get rid of this added 2 by subtracting 2 on both sides. So that gives me x squared equals 81. Now, on the very first day that we started to review solving of equations and opposite operations, one of the operations we had in the original was a squared. And you guys told me to list that the opposite of squaring is to take a square root. So if I want to undo that squared, I would square root both sides. The square root and the squared are opposite operations, which means that they undo each other. So this square root and this squared cancel each other out. The thing that's tricky about using square roots as an opposite operation is that whenever you do it, the other side has to get a plus and minus put in. Square root of 81, I would then simplify. It happens to be a perfect square, so I don't need to do a factor tree. It's a perfect square. I can just say 9. The reason we need the plus or minus is because if I square -9, that's still 81, in addition to squaring +9. So this is kind of a preview into more quadratics that we'll eventually be spending a lot of time on in second semester. So here we've got 2 solutions there. All right, last section, more inequalities, and we are going to do number 11 together. So remember the 2 differences between inequalities and equations. The first one is that your variables need to be on the left side. The second one is that if you multiply or divide by a negative number on both sides, you have to flip the symbol. So we're going to approach this, other than those 2 things, just like we would with an equation. So in this case, I've got variables on both sides. So the first thing I need to do is move all my variables. It does matter where they go. They need to go to the left. So I'm going to move this 10m by subtracting it on both sides. So those are going to cancel out. 3m minus 10m is -7m. I've still got this -2 on the left. Then less than 16. Make sure that you are writing the symbol in every single step. Next, I've got my variables on the left, which means my constants need to go to the right. So move this subtracted 2 by adding 2 on both sides. Then, oops, I could have almost made a bad mistake there, but I didn't. I forgot to bring down the negative with the 16, but I caught myself, so it's okay. So next, these have canceled. So -7m is what remains on the left side. My symbol is less than. -16 plus 2 is -14. So now I'm going to go ahead and get m by itself by dividing, because this is a multiplied -7. So I undo multiplication with division. So like we talked about yesterday, at this point, like a really loud, annoying beeping noise should go off in your head, because you just divided both sides by a negative number. And whenever you do that, the symbol has to flip. So in my next step, the symbol has flipped because I divided both sides by a negative number. So these cancel. M is by itself on the left. -14 divided by -7 is +2. So m is greater than 2 is the solution to the inequality. Now I just need to graph it. So again, it doesn't matter where you place your numbers, just as long as they're numerically correct once you place them. So if I put 0 here, let's say, then 1, 2 would be right here. So next, I need to decide which type of circle. This is a plain greater than, no extra equals, which means no extra shading. So an open circle on the 2. And then greater than means numbers bigger. So my arrow is going to go to the right. Again, the point of the symbol shows you which direction the arrow should point. So greater than to the right. So I've got it solved. I've got it graphed, which means that I'm all done. So you've got 3 additional inequalities to practice to add to what we did on the last couple worksheets. And finish up the rest. I will check it in the morning.